All right, now we get to question free response 2 from day number 10. We got a snail traveling along a path. We're given the velocity of the snail for the first 15 minutes. So part A says find the acceleration at 5. So that's easy enough. We're just going to take the derivative of this at 5. Put this on your calculator, take the derivative. You should have gotten 0.538. You didn't have to give any units on this. If you wanted, it would be inches per minute, or inches per minute squared. Either way, you get a point, units or no units. What is the displacement of the snail for 0 to 15? So displacement is the integral from 0 to 15 of just the velocity, not the absolute value. That'd be total distance traveled. We just want velocity. So you got a point for writing that integral down. And if you worked it out to 76.043, then that gave you a second point. Okay, so 3 easy points to start with. C says, at what time is the snail's instantaneous velocity equal to its average velocity? So to get the average velocity, we're going to go 1/15, 1 over 15 minus 0, times the integral from 0 to 15 of velocity. That's how we find an average value. And if you do that on your calculator, you get 5.069538. We're not going to round that, okay? We want to keep that as big as possible. That is our average velocity, so we just want to know when is the instantaneous. When does this velocity equal that value? So what we're going to do is just take that value and set it equal to our velocity. So on our calculator, we could graph that out and then graph a line here and see where they intersect. And it should intersect at 6.031 minutes. All right, so you got a point for doing the average value, and you got a point for finding the time where they intersect. All right, so we've done enough of that. I'm hoping that makes sense, but if for some reason that doesn't, send me a message and I'll be happy to show you that on the calculator. All right, then we get to D. And D says now we have an ant that comes to the starting position after the 12-minute mark, goes with a constant acceleration of 2 inches per minute, and catches the snail at time 15. We want to know how fast was that ant traveling initially at the 12-minute mark. So this one can twist you in a million different directions. I'm going to walk you through what I think is the easiest way to kind of understand it. So first off, we know that the velocity of the ant, so we're going to be talking about the ant right now, because he's going with a constant acceleration of 2 throughout the whole time, his velocity is going to be 2t plus something, all right? That's his velocity at any given moment, but we need to know what that c was, okay? We'll come back to that c in just a second. Now his position, his displacement, will be the integral of that, right? Now we actually know what his displacement is for the full 12 to 15 because he catches the snail. The snail has traveled 76.043. That's how far it is from the starting point to the 15-minute mark. So that's how far the ant traveled too. So the ant, if we integrate from 12 to 15, so from when the ant starts going to when the ant catches him, his velocity, that will give us the total distance traveled, which is, again, 76.043. Now, this goes to t squared plus ct. All right, and if we plug these values in, what ends up happening is we get 100 or 225, well, we'll just go ahead and do it. 225 plus 15c minus 144 plus 12c. And if we subtract here, we end up with 81 minus 3c equals 76.043. If we work this out, we end up with c equal to negative 1.652309. That's assuming this number was kept all the way through too. Okay, so there's our c value. Now I can plug that back in, and now we have the ant's velocity. The ant's velocity is 2t minus 1.652309. 0.09, and we want to know what the velocity was at the 12-minute mark. So put 12 in, and you'd end up with a velocity of 22.348. And that's the answer. So how the heck did they give points for this? Well, first off, if you could come up with the idea that the ant's velocity was 2t plus something, you got a point for that. If you talked about the ant's displacement being the same as the snail's, some fashion or other, you got a point for that. If you were able to come up with an equation that kind of worked those together, if you kind of had this idea here, you got a point, and then you got a point for the final answer. So a lot of different ways you could go, and again, if you twisted yourself around, I don't blame you. This one had me confused at first too, but that's probably the easiest way to navigate through it.